Hello, if you have watched the previous video, we said that the low shelf filter can reduce high frequencies, and one of its uses is to correct the negative effect of baffle loss. In this video, we're going to try this filter on a real driver. The first step is to make a constant impedance. We need an RC filter. You can learn more about it by watching this video. Their formulas are Since we need a constant impedance, it is better to adjust our one to get it. On Vituixcad, select Tools, Diffraction. In the driver specs, the maximum width is about 8.3 centimeters, and the diaphragm area is so a box width of 15 centimeters is suitable. We can eliminate this bump by rounding the edges and changing the driver position. As you can see, we have created a 15 x 20 box, and this item adjusts the roundness of the edges. 4 means 4 rounded edges. The higher the value, the more rounded the edges. After that, change the driver position. This microphone is the symbol of a measurement mic, and it should be set at the center of the driver. The baffle response is better now. Import the driver's response into this tool to see the effect of the baffle. Export the new response. Now delete the previous response and import the new one, which includes the baffle effect. Let's compare it with the original response. Now, you can see the negative effect of the baffle. The low frequencies have become weaker than the original response. Visit this website, whose link is available in the description. Design a first-order crossover using these settings. The impedance is about 3.9 ohms after correction. Enter it for the tweeter and woofer. For the frequency, using this simple formula is all you need. We determined the width of the baffle in the diffraction tool to be 0.15 meters. Since we need to reduce the high frequencies, the low-pass filter, including an inductor, is enough. I select a higher value for the inductor. You can try some values close to the calculated numbers. The parallel resistor adjusts the level of the high frequencies to be equal to the lowers. Now, the listener can hear more the low frequencies. If we don't use the low shelf filter, as if the high frequencies level don't allow the low frequencies to reach the listener ear. As I said in the previous video, baffle loss is usually 6 dB. The low shelf filter reduces the high frequencies to be equal to the low frequencies, but its negative effect is a total 6 dB loss. If you want a way not including this effect, use a transmission line. In the next video, we'll design a transmission line for this driver and compare the filter result and the transmission line. Thanks for watching.